So in this video tutorial, I would like to show you how to change the internal gain setup in our model in EnergyPlus. So let's start. Okay, so first we search the internal gain parts. So we have three internal gains here: people, lights, and electric equipment, but we still use the template setup for these internal gains. And now we would like to change the setup here according to the data that we have. So this is the data. So we have the data for each zone. So space 101, we have 4 people and 96 watts for lighting and 300 watts of electric equipment. So we want to assign this data to each zone. So first, you should click the new object here and set the name. And set the zone name. So the first one is space 101, and set the schedule name of the number of people. So to make the schedule name, you should scroll up again to the schedule part here, and here, as you can see, we have a data about the building operating hour, that is from 8 a.m. to 5 p.m. So we want to make a schedule that is based on this data. So here I'll just use the schedule compact here and click new object and set the schedule name as building operating hour, and schedule type limits name, I'll choose activity level, and then field 1, right through 31st of December, and this will be available for all days. We don't have any other information whether the building will be closed on a weekend or it still be open with these operating hours. So for now, I'll just set it as operating hour for all days. And in field 3, you should add when your building will start operating. So in this case, the building will start operating at 8 a.m. So before 8 a.m., it's still closed. So we set it as 0. And then until 5 p.m., the building will fully operate it. So we set it as 1. And then until 12 p.m., again, it will not be operated. So this is how we built a compact schedule in EnergyPlus. And then we can scroll down again to the internal gain part and input the number of people schedule name. This it is. 1 in the schedule before is mean 100%, but if you want to set the exact number of the people, you should set it here. Okay, so the number of people calculation method, I'll choose people because we have a data about number of people. So the number of people in this space is 4 people. So set the schedule to be 1, which means 100%, which means in the duration of 8 a.m. to 5 p.m., there will be 4 people always in this space. Next, I'm sorry, the number of people should be here, and we don't need to set these 2 box here because we already decided to choose the people as our calculation method. So this is the fraction radian. We'll just follow the template number, which is 1.3. And this is the activity level schedule name, so we should add another schedule here. Activity level schedule name is the amount of heat gain per person in watt per person, depends on the activities. So this is used to calculate total heat generated from human body into the zone. The activity level heat gain depends on the activities. So what are the activities? We can check it here. So from sleeping, seated, standing, and so on. And in this case, we built an office building. So the activity level heat gain range from 100 watt to 200 watt per person. 200 watts per person. So let's say we are doing typing or filling with the seated. So the around number is 120 watts per person. Here we can check it here. The activity level schedule that is being used in the template is the office activity schedule name. So we can check again what is the activity level used in this schedule. Office activity here is set to be 132, but we want it to be just 120, so we can use large office activity or medium office activity, also 120. So I think I'll just use the medium office activity schedule name. So we come back again to the internal game and set this to be medium office activity here. Okay, so that's all the input parameter that we need to assign here. And I'll delete this one and duplicate this object. So duplicate for space 102 and 103, and the number of people for these two zones is 2. So we set it to be 2 and to be 2. It has the same building operating hour, so we can use the same schedule name and assume to have the same average activity level heat gain, so we can use this one too. Okay, and next we will assign the lights. Click new object, let's say light 101 for space 101. The schedule will be the same, that is the building operating hour. And here we will use lighting level. So lighting level use what unit, so we will use this one. And the light power for space 101 is 99. And here is another input parameter that we need to add. So return air fraction, fraction radiant, fraction feasible. So here we can see some of the input parameter definition that I think are important. So first we need to assign the design level calculation method. We already did. And then fill in the return air fraction. So this one is the fraction of the heat from lights that goes into the zone return air, which means it is only available for light with return air ducted, so like this. But I assume that we use the surface mounted light. We can set this one with 0. And we can see in this table here, the fraction radian for the surface mount will be 0.72. And the fraction feasible will be 0.18. And then there's also another input parameter which is called fraction replaceable. If set to 0, no daylight control. If set to 1, the lights are allowed to be dimmed by the daylighting controls. So in this case, we assume that we do not use any daylight control. So we will set it to be 0. So that's all the input parameter that we need to fill in the light internal gains. Okay, so we can delete this one and duplicate this and change the name and the thermal zone and the lighting level. Oh, I'm sorry, I'll just delete this first and duplicate this. So if you imagine you have a really big model which consists of more than 100 of spaces, then doing this one by one will take very long time. And that is why you need to make the zone list here, like what we find in the template internal gains before, so that you can make a group of spaces that has the same input. For example, in this case, space 102 and 103 has the same data here. So you can make a zone list here so that you don't need to add one by one here. And last one, we'll add the electric equipment internal gain. Schedule name will be the same, and equipment level here 300, and also you need to define the fraction latent, the fraction radian, and fraction loss. The default is 0, 0, and 0. So here you can see the definition of each fraction. So the fraction latent will be the latent heat gain given off by electric equipment, and it will affect the moisture balance within the zone. And the fraction radian is the long wave radiation heat being given off by the electric equipment. So the radiant heat gain is absorbed by walls, floors, and furniture, and contributed to the space cooling load only after a time lag. So there will be a delay heat gain. And there is also a fraction loss. So this one is the amount of heat which is lost, which means does not impact the zone energy balances. So for example, if we use like 3000 watt of an electric equipment, and we set the fraction loss to be 1, it means that there will be no heat comes from this electric equipment to the zone. So this is, I think, is a crucial input parameter here, because each type of electric equipment will give a different fraction loss. So we need to take a look in the array to get the common fraction loss for any type of electric equipment. So we come back here again, and because we don't have any information about this electric equipment fraction here, we will just set it to 0 and assume that half of the electric equipment level will not be converted into heat. So we'll set it to be 1.5 here. Okay. We can duplicate this and set it to be 102 for space 102. Okay. Okay, so we have set all the internal gains here. You can also add another internal gains actually. For example, the infiltration will affect the cooling load and it increases the heat gain within the zone. You can also set it with the actual number that you have, but if you don't, then you can use the template. And then you also can add if you have any ventilation, but for now I will just change these 3 internal gains and let the zone infiltration to use the default number. Now we can save this and start simulating. So I'm sorry, I think I set it wrong. So it shouldn't be 31st 12, but 12 31st. Okay, let's try again. Okay, so we have got the simulation result here. Okay, here is the new total energy of the building. You can take a look on the energy and use breakdown here. And okay, we'll compare it with our previous simulation result. Okay, so basically the total energy of the building increases after we change the internal gains. And we can check the zone component load to see the cooling load breakdown. The people cooling load increases significantly because before we set it to have 1% per 17 meters square, and now in a 25 meter square space we assign 4 people. That is why the cooling load from people increases significantly. And this one is the lights. So the lights only give the sensible heat gain here, so there is no latent. So it will not affect the moisture balance. And the sensible cooling load from the lights is only 9.6. This comes from this lighting level. So as we can see here, the fraction radian for the mounted surface light is only 0.72 and the fraction visible is 0.18, which means if we sum these two, the total will be 0.9, which means there is only 0.1 of lighting level that is converted into the heat for the zone, which is 9.6. Okay, and also this one, the equipment sensible. So because we do not set the latent fraction of the equipment here, that is why all the lighting level here will be converted to the sensible. But I forget to delete this one, so that is in the space cooling load breakdown here. We got 375. It should be only a half of 300, which means 150. But here we get 375. But I think, yeah, that's okay. Okay, that is how the internal gains correlated to the cooling load here. Okay, I think that is for this video. Hopefully you can understand how to change the internal gain setup in EnergyPlus and know what each input parameters are for. See you in the next video.